Okay, hello everyone. So we are going to do our lesson on ions. So this is not going to be included on your chemistry quiz number 2. This is just simply continuing on to the last part of our chemistry unit. So ions are different from atoms. Okay, so let's review what an atom is. So an atom has a neutral charge, right? So atoms have charges of 0, right? So meaning the number of protons is equal to the number of electrons, right? So if I have 9, positive 9, right? So 9 protons and I have 9 electrons. Sorry, I'm writing with my mouse. It's awful. Just bear with me. So I have positive 9 because I have 9 protons and I have negative 9 because I have 9 electrons. That adds up to a net of 0, right? Or neutral. But we can have an atom that will become an ion. Okay, so an ion is an atom that has a charge. So meaning it's not neutral, but it's either positive or it's negative. So there's two ways that atoms can become ions. You can either gain electrons or lose electrons. But that is the key. The key is the only thing that can change to make an atom an ion is the number of electrons. So if you have less electrons, right, if you're losing electrons, the ion will become positively charged. So let's use this as an example. If I have positive 9, and let's say instead of 9 electrons, I have 8 electrons, I'd have positive 9 and I'd have negative 8. So that would add up to a charge of positive 1. Right? I have one extra proton than I have an electron. I've lost an electron. If I lose 2 electrons, that's like positive 9, negative 7, I'd have positive 2. But regardless, however many electrons that are being lost, you have a positive charged outcome. If I gain electrons, what happens there is you have more negative charges. So overall, the ion will become negative. So let's go back to the 9 and 9 example. Let's say instead of 9 electrons, I had 10 electrons. So if I had positive 9, right, positive 9, but then I had negative 10, right, I have one extra electron. Overall, my charge would be negative 1 now. Right? So by losing electrons, it becomes positive. By gaining electrons, it becomes negative. So you have to think, electrons are negatively charged. So if you have more of them, you're going to have more negatives than positives. So why do atoms want to become ions anyways? Okay, so this is the key. The whole purpose of making an ion is so that the atom can become stable. Okay, so let's explain what stable means. Stable means that the valence shell, so if you remember what we talked about the other day, the valence shell is the last orbit on your Bohr-Rutherford diagram. Okay, so the valence shell, for it to be stable, means that it has to be completely full. So to have a full valence shell, that means that it would be a stable ion. Now, if it is not full, it is not stable. Okay, so just to review, the first shell or the first orbit that you draw on an atom can only hold a max of 2 electrons. Every other orbit holds a max of 8. So that means if you had 2 electrons and 8 electrons here, those shells would be stable because they're completely full. If it is not full, so let's say we had, 7 out of 8 electrons on the outside orbit, that means it is not stable. So that's why atoms would become ions. And I'm going to show you when we look at Bohr-Rutherford's that it'll make more sense when you see an example. Okay, so let's look at sodium. So sodium has 11 protons. Remember, that's the atomic number, and it has 11 electrons. Okay, so for the number of neutrons, I believe we have 12, right? So we have 24 3 minus 11, right? So we have 12 neutrons. Okay, so let's look at the Bohr Rutherford. Okay, so I'm using a mouse here, so just bear with me. So protons are going to go in the middle. Oof. Okay, obviously yours is going to be nicer than this. Can you write in the number of neutrons too? So the number of neutrons here is going to be 12. Ooh, okay. Anyway, I'm going to verbally say this. The important part is going to be our valence, our electrons anyways. But inside here, you should have number of protons, number of neutrons. Protons is 11, neutrons is 12. Okay? So we're now going to draw our 11 electrons. Okay, so our first orbit can hold a max of 2. There's 1, and there's 2. Okay, so there's our 2 electrons. We need 9 more. Okay, so we're going to draw another orbit. Okay, and we're going to have a full 8 on here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there is we have 10 so far. So we need 1 more. So we need a total of 11. Okay, so our outside orbit, I'm going to draw it down here just so we have more space we can actually see it. Okay, but normally I draw it at the top. The point is there's just 1, so it can go on the top or the bottom. Okay, so here's sodium, our Bohr Rutherford diagram. So if you look at the outside shell, the last one we drew, there is 1 electron, right? So on this last orbit, there's 1 valence electron. So remember, the whole point of something being stable is to have this outside orbit be full. Let's go back to that. So the whole point is to become stable. So when the valence shell is not full, it is not stable. So here, we only have 1. The maximum this can hold is actually 8. So remember that we can either gain electrons or we can lose electrons. But the point is we want to have our outside shell being full. So what happens here is sodium can either gain 7 more electrons to make this 8. Remember, the maximum that can hold on this orbit is 8. Or we can choose to lose an electron. And what would happen then is this last orbit would then essentially be gone. And then the inside orbit, if you take a look, would now be completely full. So atoms will do whatever takes the least amount of energy, like whichever option is the lower amount of energy to become stable. So for sodium, the question is it easier to lose 1 electron to get rid of this outside shell, or is it easier to gain 7? So of course, I'm hoping you can kind of see, right? It's easier to lose 1 than to gain another 7. So what's going to happen here is it's going to lose 1. Okay, oh my goodness. So please write in there, lose 1. So it is easier to lose 1 electron than it is to gain 7 electrons, right? So you have to imagine this whole outside shell would then be gone. Okay, so here's a main driving point. All metal elements will lose electrons. Okay, so all of the metals on the periodic table, if you look at their Bohr Rutherfords, it will always be easier for them to lose electrons, and what ends up happening then is the ion will become positively charged. Okay, so you have to imagine, actually, if we lost 1 electron, we would become positive 1. We'll talk more about charges in a bit. Okay, next we have oxygen atom. So let's draw the Bohr Rutherford for oxygen. So we have here protons are 8, electrons are 8, and actually neutrons is also 8. Okay, so please do me a favor. Let's do this nice and big. Right? So proton number is 8. Our neutron number is 8. Please make sure you're filling that in. Okay, so we're going to start drawing our electrons. Right, so our first orbit is 2 electrons. Right, so 2 out of the 8. And our second orbit, oh my goodness, is going to have, I hope everyone's having a good laugh out there, okay? Actually, let me fix this. This is so bad. The things I do here, right? Okay, so we have 8 electrons total. So we have 1, 2. So we have 3, 4, 5, 6, 7, 8. Okay, so we have all 8 electrons. So let's look at the valence shell. So this is one here. The valence shell, or the valence orbit, is the last one we just drew. There are 1, 2, 3, 4, 5, 6 electrons that are valence electrons here. Okay, so the whole point of becoming an ion is to make this outside shell full, right, to become stable. So that means oxygen either has to lose all 6 of these electrons or gain 2. So the whole point, remember, the maximum we can fit here is 8. So the one that takes up the lower amount of energy is always the one that will be completed. So it's easier to gain 2 than it is to lose all of the 6 electrons here. Okay, so what ends up happening is it will gain 2. That's exactly what will happen. So it will become a charge of -2. So here is the general point. Okay, all nonmetals, so remember we talked about metals and nonmetals, nonmetals will always gain electrons and become negative charges. So metals become positive, nonmetals become negative. Okay, that's a main point. Okay, so let's look at neon. So neon has 10 protons and it has 10 electrons, and it happens to have 10 neutrons as well. Okay, so let's take a look at neon. So neon, please write in here protons being 10, right? And then our neutrons being 10. Please make sure you're writing this nice and big so you have space. And let's start putting in our electrons. So we have 10 electrons. So we have, I'm going to use X's. I find that it's going to be easier for me to draw them out here. So here's 2. So we have 2 out of our 10. And we're going to draw our next orbit. And this orbit's going to have a full 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can use circles. If you want to use X's, that's acceptable too. Okay, so in total we have 2 plus the 8, we have our 10 electrons. Okay, so let's look at our outside shell. Our outside shell has 8 electrons. Okay, it's already full. So neon actually will not make an ion. Actually, none of the elements that are in the same family as neon will actually create an ion. They are, if you remember, they are the noble gases, and they are very unreactive. That's actually the main reason why they are so unreactive. It's because they already have a full valence shell. So there's no need for them to do any sort of chemical reaction or changes. So you're probably wondering, well, do we have to draw a Bohr-Rutherford every single time when we're talking about ions? Well, actually, I'm going to show you a way to look at the periodic table to see how many valence electrons there are. Okay, so this is not exactly the same periodic table as the one that you have in class, but obviously it's the same kind of setup, you know what I mean? So we have our 18 groups and we have our periods.